This is Unit 2 for the subject English Language Software Engineering. In this unit, we will talk about software development lifecycle and about different models used for development of software. Software engineering is a systematic and disciplined approach to developing, operating, and maintenance of software. Once upon a time, software development consisted of a programmer writing code to solve a problem or automate a procedure. Nowadays, systems are so big and complex that teams of architects, analysts, programmers, testers, and users must work together to create millions of lines of custom-written code that drive our enterprises. Let's remember what are the main stages in the process of developing software. The first phase is project planning. This phase establishes a high-level view of the intended project and determines its goals. Next phase is systems analysis and requirements definition. This phase refines project goals into defined functions and operation of the intended application. It also analyzes end-user information needs. Systems design is the next phase. It describes desired features and operations in detail, including screen layouts, business rules, process diagrams, pseudocode, and other documentation. After that, we have implementation. The real code is written here. The following phase is integration and testing. This phase brings all the pieces together into a special testing environment, then checks for errors, bugs, and interoperability. After testing, software documentation is made. The following phase is acceptance, installation, and deployment, and this is the final stage of initial development, where the software is put into production and runs actual business. The last stage is maintenance. It refers to everything that happens during the rest of the software's life: changes, correction, additions, moving to a different computing platform, and more. This, the least glamorous and perhaps most important step of all, goes on seemingly forever. What is the purpose of the software development lifecycle? The purpose of the software development lifecycle is to minimize the cost of the software over its lifespan. System features must be identified as early as possible in the lifecycle. Without project management, software projects can easily be delivered late or over budget. With large numbers of software projects not meeting their expectations in terms of functionality, cost, or delivery schedule, effective project management is proving difficult. Here is the list of the commonly used software development lifecycle models: waterfall, iterative, agile, and extreme. The waterfall model is the earliest software development lifecycle approach that was used for software development. It is also referred to as a linear sequential lifecycle model. It is very simple to understand and use. In a waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping in the phases. After each step is finished, the process proceeds to the next step, just as builders don't revise the foundation of a house after the framing has been erected. If iteration is not included in the planning, the process has no provision for correcting errors in early steps, for example in the requirements, so the entire engineering process may be executed to the end, resulting in unusable or unneeded software features. Some situations where the use of the waterfall model is the most appropriate are when the requirements are very well documented, clear, and fixed, when the product definition is stable, when the technology is understood and not dynamic, when there are no ambiguous requirements, and when the project is short. What would be the advantages of a waterfall process? The advantage of a waterfall development is that it allows control. A schedule can be set with deadlines for each stage of development, and a product can proceed through the development process model phases one by one. Each phase of development proceeds in strict order. The main disadvantage of a waterfall process lies in the fact that there is no going back to the previous process, which means that the process has no provision for correcting errors in early steps, for example in the phase of analyzing requirements. So the entire expensive engineering process may be executed to the end, resulting in unusable or unneeded software features. This is a diagram showing the waterfall model process. In iterative model, iterative process starts with a simple implementation of a small set of the software requirements and iteratively enhances the evolving versions until the complete system is implemented and ready to be deployed. An iterative lifecycle model does not attempt to start with the full specification of requirements. Instead, development begins by specifying and implementing just part of the software, which is then reviewed in order to identify further requirements. This process is then repeated, producing a new version of the software at the end of each iteration of the model. The main advantage of this model is that there is a working model of the system at a very early stage of development, which makes it easier to find functional or design flaws. Finding issues at an early stage of development enables to take corrective measures in a limited budget. Some other advantages of this model are the following. With every increment, operational product is delivered. This means that working functionalities can be developed quickly and early in the life cycle. Parallel development can be planned. Progress can be easily measured. The main disadvantages of this model are the following. More management attention is required. It is not suitable for smaller projects because it is hard to break a small software system into further small serviceable increments or modules. End of a project may not be known, which is a risk. Highly skilled resources are required for risk analysis. Project's progress is highly dependent upon the risk analysis phase. Agile model is a combination of iterative and incremental process models which focus on process adaptability and customer satisfaction by rapid delivery of working software product. Agile methods break the product into small incremental builds. These builds are provided in iterations. Each iteration typically lasts from about 1 to 3 weeks. Every iteration involves cross-functional teams working simultaneously on various areas like planning, requirements analysis, design, coding, unit testing, and acceptance testing. At the end of each iteration, a working product is displayed to the customer and important stakeholder. Agile model is based on the adaptive software development methods, whereas the traditional software development lifecycle models like waterfall model is based on predictive approach. Predictive teams in the traditional models usually work with detailed planning and have a complete forecast of the exact tasks and features to be delivered in the next few months or during the product lifecycle. Predictive methods entirely depend on the requirements analysis and planning done in the beginning of a cycle. Any changes to be incorporated go through a strict change control management. Agile model is based on the adaptive software development methods, whereas the traditional software development lifecycle models like waterfall model is based on predictive approach. Predictive teams in the traditional models usually work with detailed planning and have a complete forecast of the exact tasks and features to be delivered in the next few months or during the product lifecycle. Predictive methods entirely depend on the requirement analysis and planning done in the beginning of the cycle. Any changes to be incorporated go through a strict change control management. Agile model uses adaptive approach where there is no detailed planning and there is clarity on future tasks only in respect of what features need to be developed. There is feature-driven development and the team adapts to the changing product requirements dynamically. The product is tested very frequently through the release iterations, minimizing the risk of any major failures in future. Customer interaction is the backbone of agile methodology, and open communication with minimum documentation are the typical features of agile development environment. Some of the advantages of the agile model are the following. It promotes teamwork and cross-training. Functionalities can be developed rapidly. Resource requirements are minimum. It is suitable for fixed or changing requirements. It is a good model for environments that change steadily. It has minimal rules and the documentation is easily employed. It enables concurrent development and delivery within an overall planned context. It is easy to manage and it gives flexibility to developers. Some of the cons of this model are the following. It is not suitable for handling complex dependencies. It depends heavily on customer interaction, so if the customer is not clear, team can be driven in the wrong direction. There is very high individual dependency since there is minimum documentation generated. Transfer of technology to new team members may be quite challenging due to lack of the documentation. This is the diagram showing the agile development model. Extreme programming is the best known agile process. In extreme programming, the phases are carried out in extremely small or continuous steps. The first pass through the steps might take a day or a week rather than the months or years of each complete step in the waterfall model. From a practical point of view, extreme programming encourages pair programming, where developers always work in pairs, and test-driven development, where unit tests are always created in conjunction with the system under development. Extreme programming may be a good choice for prototype technologies and research projects. Most software projects use combination of different aspects of all methodologies mentioned, which are based on sound software engineering principles and practices. The most important part of success and failure of software development projects is usually not a particular methodology, but clear communication, hard work, and common sense. What do you think? Is this how the software development process usually looks like? If you have any questions about the topic discussed, feel free to send them to iris@edu.fit.ba or ask them in our next term for online consultations.